skipping the warm-up. And we're going to plot these points in the coordinate plane. You do also want to label the points with A, B, C, and D. And then in order to prove what the shape is, we start with slope, because I can narrow it down, see how many pairs of parallel sides we have. So what would the slope from A to B be? What would be the slope from A to B? Marquise? 5 over 1. 1, 2, 3, 4, 5 over 1. How about the slope from B to C? Who thinks they could calculate that for us? Marquise?
-3/4.
Down 3 over 1, 2, 3, 4. -3/4. Someone I haven't heard from. Slope of CD. If you don't volunteer, I'm going to volunteer you. Maddie? 5 over 1 again. If you start with C, notice that you do go down 5, but you also go backwards 1. So that would really be -5 over -1, which does become just 5 over 1. I would usually start with D and then go up 5 over 1, so I don't have to worry about going backwards, but just make sure you realize that. Just 5. And the slope from A to D or D to A would be? Kale?
3 over -4.
3 over -4 or -3 over 4. It doesn't matter where you put that negative, but it is a negative fraction. So from this point, we can tell that these are the same number. So that tells me that AB is parallel to CD. And if you want, you can mark it in your picture. We also know that BC is parallel to DA. So if we have two pairs of parallel sides, none of which are right angles, right? There are no perpendicular segments. What are our two options at this point? What shapes have two pairs of parallel sides, and none of them are right angles, necessarily? Marquise? A parallelogram. Or what? Maddie? A rhombus. Again, we're going to exclude the rectangle and the square from our list because we do not see right angles being formed based on the slopes. So now we just have to do our distance formula 4 times and verify whether or not we have all 4 being the same, or in a parallelogram we will learn later on in the year that the opposite sides are going to be congruent. You'll probably notice that, but that's a theorem, not the definition. So now we do the distance formula with all of these points. So again, make sure you scribbled out these points. Those are the wrong points. So A was -3, 2. And B was -2, 7. And we're going to do our distance formula with that. And this comes out to be the same as yesterday. The shape isn't the same answer as yesterday, but the first one is the square root of 26. We did get yesterday in one of our houses. Well, let's do CD. So C had coordinates 2, 4. And D had coordinates 1, -1. Some students are like, after I do 2, I know what shape it is. And I agree with you. You can figure it out by 2, but it's a coordinate proof where you're proving it matches all of the properties. So you have to show all 4, unfortunately. I know it is time consuming and tedious, but you have to do all 4. And that's why you only have one of these on your homework, one of these on your test. Make sure that you remember when you square a negative number that, I think your CD is below and then your BC is over here, I think. But this one's going to give me the same number. 9 And again, if you're someone who types everything in your calculator, make sure you put parentheses around it before you square it. Because if you do square it with just a negative, it'll actually tell you the wrong answer. This would be a positive 1 plus a positive 25 gets me a positive 26. That was CD. So that was right below it. Okay, so right now it's looking like I have a rhombus because I have two pairs of congruent sides. We have to do the third one. So see if you can do BC. Again, I just like to recopy the points down here just because sometimes I'm likely to make a mistake just by glancing up and looking at the wrong point. Should be getting an actual square root of 25, which is 5. So you can see that it's definitely not a rhombus, but I would verify that the slope of dA, just for the sake of time, I'm going to cut this problem short. You will get that dA is the square root of 25, which is 5. So what that's telling us is that we have opposite sides that are congruent, but not all 4. So based on the two options we had from above, it can't be a rhombus, it has to be a parallelogram. Okay, you will see one more of these on your homework tonight, so make sure you do all 8 steps, 4 slopes, 4 distances. And then make sure you do the final answer, that's really important too. That's the whole point of the problem. All right, on the back we just have a couple more, actually numerical problems given a description. So please make sure in the homework when it tells you what it is, mark the picture to show that it's a parallelogram. A parallelogram has 2 pairs of parallel sides. And they're opposite. So the top is parallel to the bottom, and the left is parallel to the right. If you don't mark that, you're not going to know what to do. Okay, and then based on parallel, we should see some types of angles that we know. Anyone able to identify what one of those angles would be using either corresponding, alternate interior, alternate exterior, same side interior? Joseph?
Angle 1 is 38 degrees.
Good. Angle 1 is 38 degrees. These would be what type, Joseph?
Alternate interior.
Good. These are alternating across the transversal, and they're inside my parallel lines. I'm just going to write it in the picture for the sake of time. And then, how can we figure out what angle 2 is? Marquise? Triangle sum. The third angles theorem is if we knew that 2 angles were congruent to 2 angles, then the thirds would be congruent as well. But I think you were kind of meaning the same thing. So we would use our triangle sum theorem, which we know adds up to 180. So we'll subtract 99, and we'll subtract 38 from 180, or add them and then subtract. And what do we get, Luke?
43.
43, very good. And then how can we figure out what 3 is? Maddie? Good. You use alternate interior angles again, because we also know those are parallel. So this would be 43, and then if we do triangle sum, it's going to have to be the same as this angle, which is 99. Very nice. See if you guys can figure out example 3 while I'm passing out your homework. It is only a trapezoid, not an isosceles trapezoid, just a trapezoid. So you would mark the top side and the bottom side are parallel, only one pair of parallel this time. In this picture, what type do we see that could help us find the missing angles? Do we see alternate interior, alternate exterior, same side exterior, corresponding? Maddie?
Could you use same side interior to find the other?
Yes, because we know these are parallel, and those of you that liked your highlighters for parallel lines, these are parallel lines. So we have 2 transversals. We have transversal 1, and we have transversal 2. Remember, you can only go along one transversal. You can't jump from transversal to transversal. So these two angles right here, just like Maddie said, would be same side interior angles. They're on the same side of the transversal and they're inside of the parallel lines, which we know are supplementary. So how big would that angle have to be? Joseph?
180 degrees.
No. It's supplementary with this.
That'd be 75.
75. That's the thing to pay attention to here. Since it's not a parallelogram, these two are not supplementary because these are not parallel. These two are supplementary. So that's why I say maybe highlight the parallel lines to remind yourself, because that's the only way you can screw this up and you can put the numbers in the wrong spots. Okay, so you kind of give away the answer for the second one. These two angles are also same side interior. And those two are same side interior. These two are not same side interior because those lines aren't parallel. Okay. So this one will get us 108. Now, if it were an isosceles, just to give you like another example, if I were to tell you it's an isosceles, you would actually know that the two base angles will be congruent. So like if this was 72, this would be 72, and then your tops would be 108 and 108. So if it does have markings for isosceles, just like in an isosceles triangle, we have two base angles congruent. In an isosceles trapezoid, you'll also have two base angles congruent, if you were to see them. Okay, real quick, the closure. Who could name this figure in as many ways as possible? As many ways as possible. Probably should have parallel markings, I guess. What do you call that? Joseph? A rhombus is the most precise name. Yes? Yep. Very good. And then the second one, only two names for this one. Maddie? Very good. Trapezoid and quadrilateral. Okay, so the homework, top section, judging by appearances, classify in as many ways as possible. So you are judging by how it looks, okay? There's no markings on any of them, you're judging it. And then you have 3 of the coordinate proofs where you're coming up with the appropriate description based on its distance